Thank you for having me. My name is Paul. I'm the lead engineer at Motiva. So Motiva is a pretty new company. We started in March. We are a spin-off company from the Data Guild. And we are based in Palo Alto. So the first question you might have is, why is this guy here? Actually, it's not only me. Our CTO Chris is here. CEO Dave is also here. And the fourth member, Matt, is actually flying in right now. So we are having a company retreat in your beautiful country. That's why we're here. But jokes aside, this talk is about interdisciplinary collaboration. And as a data scientist, you guys probably work with many different people: designers, engineers, sales, marketing, whatever. And although you guys probably heard about multidisciplinary collaboration, and that's actually there is a difference. To tell that there's a story behind this. About 12 years ago, I was an aerospace engineer working on the power simulation module for the International Space Station. So basically, we're doing a test for the test of that module. So in the typical engineering team, we have designers and we have QAs. But basically, the designers they take the specifications, design the circuits, to make sure that everything kind of fits within that. And as the QA person, the team, we are making sure that everything that they are designing, we can test them, we make sure everything, circuits and everything is adhering to the specs. The thing is, that is a multidisciplinary team. We have designers and QA guys. But the difference in that is we don't really talk to each other. We do stuff on reports and documents and things like that. We rarely even sit in the same room together. So that's the difference between multidisciplinary collaboration, which is experts in a team, they do their own thing, whereas interdisciplinary collaboration is experts in the team, they work together and learn from each other. So the rest of this talk is about 3 of the problems we have faced, and how the actual solution actually forced us to be using interdisciplinary collaboration. So who are we? Motiva, yes. We haven't actually launched, so if you go to our website, motiva.ai, this is a blank page, nothing going on right now.
It's called stealth.
So in a nutshell, and in kind of really simplistically, we kind of do email marketing, like the hundreds of companies out there that's doing the same thing. And we believe we have a better solution that will be better for everybody. So that everybody that is doing this say the same thing, but you just have to, for the purpose of this talk, that's all you need to know. We do slightly more than A/B testing, so kind of hand waving kind of thing. We do email marketing. Let's put it that way. Is that good? Actually, this is the first time we are presenting with you.
We'll talk later. That's what retreat is for.
All right. So it's not only the engineer and the machine learning or data science. Whoever pays the highest, whichever title has the highest salary nowadays, I kind of lost track already. Researcher, engineer, designer, product manager. So for this talk, we're focusing on the upper band. How is the collaboration between the engineering and the design team with the researcher, because you guys are data scientists, researchers, students, or and here, Chris, our CTO, he does his magic, whatever that is. And the outcome of his research gets extracted into a machine learning module, whereby the system that the engineers are building make use of them in a production system, such that it's not only within the realm of like a iPad notebook, Jupyter notebooks, but it's like millions of people can make use of it. And nothing about data this time, so sorry about that.
That's all right.
All right, problem 1. You have your research code. How do you actually make them, transform them into like production? So that millions, hundreds, whatever number you can, people can use of it. We've considered a couple of solutions, options. One is to use a framework. We are not the first machine learning company out there. People have done this already. They don't have to reinvent the wheel. There are frameworks out there. One of the most talked about, TensorFlow. I'm sure you guys, anybody that not heard about TensorFlow. Yeah, the problem with that for us is we are still trying to figure out what we're doing. So the thing with using a framework is you're going to have to stick to their paradigm. You have to do things their way. So that's why I was asking earlier, like, why build your thing in-house. So for us, we are quite new, 3 months, still trying to figure out like, what is the problem. And using a framework or using anything in engineering is like building the right thing for the right task, building the right part for the right, something like that. So we want to do things the hard way, essentially, so that we feel the pain point. It's like building a product, we kind of need to understand what is the pain point of the and then kind of solve the solutions, build something to solve. And the same for design process in engineering, you kind of have to deal with that and then resolve it. So the second option is just to rewrite everything, C++, Java, Clojure fans. So anybody that uses Clojure will actually know what Clojure is. Yes. So Clojure is this from Java virtual machine. The thing with that is, people often do that for performance reasons. For our sake, we haven't actually launched, so as long as it works, it's okay for us. So performance is not an issue. But the biggest cons is actually supposed to work. You need to have the researcher code it, make sure that everything's working, and then you have to transfer everything to the production system, which is something entirely different. Actually, have to write the same thing twice. Not for us, because 4 people, 1.5 engineers, don't have time for that. So the last choice we consider is just refactoring. Use the same code for machine learning, research, and for production system, the best of both worlds. Or is that true? So that actually depends a lot on because we are starting from the research code and then moving them to production code. So the starting point is really important. The quality of that research code is highly dependent. Kind of makes or breaks it. So luckily, Chris actually writes pretty good code, so we are able to make that move. Thing with so when I'm talking about research code and production code, those are implementations. That's the actual outcome. And kind of going back to when you think about building a product, what is the use case? What are the use cases? So for this particular machine learning component, there are 2 use cases. One is on the research aspect, the other is in the production system. So there's 2 systems using the same code. What can we do about it? Essentially, this is making use of a library, same as how you might call NumPy in Python. You import library, use it in one place or some other places. It's the same idea. So, and the beauty of that is the research code is actually the same as the production code. We kind of abstracted the common brain, which we call BERT, for some reason. And everybody can use the same thing, so no copying, pasting, everything's kind of checked in, Git and all that. A really good library, which I referenced here, is, I'm assuming everybody's using Python here. So you can actually have your own private PyPy, is that what we call it, pip repository to host your own private libraries. So this is the link. We just host everything on S3 without having to run the server, so it's really convenient. So that was one, using the library to abstract away code is one best practices from the engineering world. And again, I'm speaking as an engineer to you guys, the data scientists, researchers. So this, from my perspective, there are some other practices or ideas that are useful that actually we've been coming across as we've been doing this project is the difference between libraries and servers. When we abstract away BERT is a library. It's run in memory in the process of the thing that's running it, whereas the production server itself is a service. everything's out of memory. You actually don't know who's actually calling it. That actually has a bunch of implications in that data persistence. If you keep track of states in your machine learning code, whatever that is, it doesn't work at all because you might have one person using it, you might have 1,000 people using it, and that thing might be on one server, it could be on n servers. So you cannot keep states in these. So these are like, I'm not going to go through all of them. States versus functions. I'll put the slides up there. You guys can go back to the pages. But if you do these, if you actually just become aware of, become conscious of these, your engineering people will be really thankful for you. So here comes the first takeaway message from this talk. Is between working with different people, just share your best practices and learn from each other. Something that we're seeing a lot of the time. So let's step away a level deeper into the machine learning module. We're still in this realm here. The two places that's calling it, let's dive into it and level deeper in this. So the machine learning is essentially what I call the research code. The production server wrapped this research code inside. And this section I'll be talking about the client server, microservice architecture. Essentially, I won't get into that because it's more engineering side. But essentially, a service, you can think of it like suppose we have like a coffee as a service API. You call it API. Hey, I want a coffee. Make it happen, and then you get coffee back. That's API. So we have this BERT or machine learning API in-house. And how do we actually design something like this?
Can I ask one question?
Yeah.
Why is machine learning specific here? What's specific about embedding machine learning? It's part of the system. Is it then different than it would be any other thing?
Good question, because I think this component can be anything. It can be a coffee as a service. Could be, I think the point of this is collaboration. So because it's a data science meetup, it could be anything else. So yeah, it's a good one. So I'm going to step through how we design something like this, an API for in-house. There is a point to this. Get to that. We have the system, we have the machine learning module, and we have external service. That can be MailChimp, Salesforce, or whatever. And when a user activates our email campaign, you load contacts from the external service, you initialize the campaign from the machine learning module, and then you actually get the experiment batch. Think of it as if it's an A/B testing, 50% have that treatment, 50% have the other treatment, for example. And then let's take the last API. So each one of these is an API endpoint. So think about the sequence of the actions. So from these we can transfer into particular endpoints or the actions, the verbs essentially. So let's dive into the last one, get experiment batch. To get batch, we actually don't really need inputs, just get whatever we have. There are some like which algorithms or which campaigns and so on, that's trivial. And from the sequence diagrams, API definition, we have this is actually the production server for API. We actually use the Flask. On top of that, we have this Flask First Plus, which is a Swagger API. The beauty of this is the code is documentation. So all this is generated as a bonus plus. We make use of that particular API. So again, documentation. So if we forget what this some other engineers using this service, we can always jump to the server's HTTP endpoint and take a look at can actually try anything there. So it's, the second takeaway message, optimize your design choices. Couple benefits to this. One is it makes everything quite formalized. So we have the sequence of, we have this API when we build, what are the sequences, what are the definitions of the API, and then the outcome. The second more practical and somewhat silly reason is, which I actually think is the real reason. Suppose like 3 months from now. Right now we think this is the best API ever and we love it so much, but a couple months from now, I'm pretty sure I'm going to forget what I actually did, and we probably thinking, hey, we should be doing something else. And so having documentation like this, we can go back, what are the thinking process? Not only the outcome, but how did we actually come about to this, to reason about this. So that's quite important for us. So documents. Alright, so we've gone through quite a rigorous process, document everything, so nothing can go wrong, right? So actually I'm going to run a simple experiment here right now. Raise your hand if you know what SQL is. Keep your hands raised. If you're thinking about sales qualified lead, keep your hands up there. Sales qualified lead SQL. So that's something Dave has been using a lot. SQL, sales qualified lead, whereas as data scientists and engineers, researchers, SQL, the querying language for databases. So even for something simple like that, there can be a difference in definitions. So that's something I actually personally struggle with. This get experiment batch. So it's pretty simple. You make a call, you get your batch, right? So this is the unit test for that. I actually spent at least 12 hours debugging this. The thing is, I could not figure out what's wrong with it. The unit testing for the machine learning modules is working, everything's working. I ended up digging into Flask, the source code, and the Flask REST+ libraries, everything. Because this is the first time I was using those libraries, so I thought I might be doing something wrong, just crashing here and there. So what's wrong with it? It turns out, for me, GET is something really specific. As an engineer, in terms of the REST API, GET, post, put is a particular formal definition. GET is when you get something. Put is when you update an object. Post is when you create an object. And there's also delete. For this, not pointing fingers, but GET in this library is actually updating the treatments. So we actually need to do a put request before calling GET. This is okay in 99% of the times, but when we activate the campaign for the first time, I just assume we have no data, therefore I did not put the updated information for that GET. So that was the reason why I crashed. And that was like a 3 lines of code within the actual implementation, that if I just spend like 5 minutes or even 2 minutes thinking about it, I should look at that first before diving into all the open source library out there that I've been using. But the thing is, GET is so fundamental to me that I didn't really click. This doesn't occur to me that GET is not only a GET. So that was something like a silly, they well used. So going forward, we're going to be doing a lot of pair programming, especially when we are first designing a component or system, library, or whatever. Pretty funny comment up here, but they are, for this particular example, if Chris and I were sitting together, that could be not that instantaneously. So this is the last takeaway message. Documents, share best practices, just sit together, work with your colleagues. I think that's the best way. Kind of a cop out for this, but I think for the things we'll be doing next.
The interesting thing about this last point is Paul is based in Copenhagen, we're based in Palo Alto. So the pairing point is actually salient, I think, maybe for this audience, because it requires us collaborating across great distances.
Yeah, this is actually the first time I've seen these guys in person since March. So. Hyper excited. Yeah, in summary, best practices, documents, and yeah. Any questions?
We haven't said anything about actually machine learning that you're using, so you're using
Nope,
some methods.
not at all, because I'm not machine learning. You can ask that guy. You can invite him back next year or something.
Now you're pointing fingers.
No, but the takeaway for this talk is just seeing it from another perspective. It takes more than one person to build a product. You guys are doing your magic out there. You want people to be using your product. So how do you take that step? I think we are in a particular interesting position in that this is a quite early stage company, 3 months. It's something you guys might be seeing soon.
I think the other point, though, to that, and given our experience at the Data Guild with building product companies like this, is that some of the most interesting, bigger problems out there require this level of interdisciplinary collaboration. And it's very rare, even in the Valley, to have effective teams like this actually working to build products together. And so it's not obvious how you build really compelling machine learning backed products. There's lots of analytics companies out here, as you well know. Very few really compelling products that are built on top of advanced methods like this. And it requires this kind of communication. If that's any kind of special sauce we have, it's this ability to cross-communicate. And we're still learning this, as Paul mentioned.
One question. How do you communicate? You being in Europe and the other guys being in the States?
Yeah.
There's
Lots of
not a lot of
experimentation.
overlap time when you're not sleeping, when the other guys are not sleeping. What tools do you use to collaborate?
We try to be asynchronous as much as possible. So that's also a reason for the overall documentation and everything. We also have a daily setup, so that's part of the extreme program. I don't know what it is. Agile methodology. Yeah. So every day we have a 5-day setup. That kind of thing. We are also on Slack. IRC, whatever, Slack.
Yeah. Recurrent choice is like a meeting for meetings.
Yeah.
We'll use the video.
Yeah, it's mostly just finding a rhythm within the team. Everybody's different. It took us a while to kind of get on that.
The other thing too is that, as Paul and I were establishing our common language, one of the things that we did institute was having a weekly period of time where we can just kind of have literally unstructured conversation. So there really isn't necessarily an agenda. And this is, one of the downsides to being remote is like, I've worked for over a decade in a research environment, and I always used to tell people most of my best conversations happen on the way to the bathroom, right? And actually one of the things I instituted there where I was working was I got whiteboards put up in the hallway, because while I'm on my way to the bathroom and I meet that random person and we're both free and there's no agenda, and I'm like, hey, I was thinking about blah, 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 and then our conversation just spirals and amazing ideas come to the fore, and the whiteboard's there, like, Paul and I don't have those kind of unstructured moments. So, we sort of have to try to engineer that, but it's, how do you engineer serendipity? It's hard. So, so we're experimenting, trying to find ways around, some of the things that you lose when you're in the same physical space.
I never have any bookings. We can have these company retreats.
Yeah. Are there any other benefits besides the accountability? Working remotely?
I've actually been working remotely for the past 4 jobs. So there are pros and cons.
Yeah.
Can be anywhere, but at the same time, you have to be working.
Okay, what are the pros?
So I'll throw out a pro. we met. Paul met one of our colleagues, had a conversation, and our colleague Paco said, hey, you need to go talk to these guys. So, and basically Paul walks in our front door, and we did zero work to find him. And, basically what we find over time is like the world's best people, they're unfortunately not all in one place. Right? So we feel truly blessed to have the people that we do in our community that we've nurtured. And they're all over. There's a bunch that are for us in the San Francisco Bay Area, but there are other people that are all over the place. And so being flexible, being open to that, kind of geographic diversity gives us the benefit of being able to take advantage of the brightest minds that are out there wherever we may find them.
Any other questions?
Have you thought about potential problems or even challenges you will have when scaling up the system, or do you think the current machine learning part will be solved fast enough so it won't be needed?
Actually, yeah. We can look into other interdisciplinary teams in that. How do you have front-end engineers, back-end engineers, designers, programmers work together? From places like Spotify, people have this small teams, even within like a dominant company. You just work with the people around you, 5, 6 people, you perform these tasks interdisciplinary teams. So having that small teams and have them stick together, that would be something other people have done for other disciplines. It will be something that we have maybe we can build that.
Yeah, that's actually a question that we want to address in the next couple of weeks while we're here. And it goes to the culture we'd like to build as a company as it grows. So this is the DNA. And we want to make sure the right DNA propagates into the future so that we build the strongest possible capability from a product team building. So I think we'll be flexible, we'll figure it out over time, and we want to establish some principles. And Paul's laid out a few of those here.
So, with this machine learning, especially deep learning and so on, there's this big unexplored thing that's called the technical debt. It hasn't been so many players and it hasn't been around for long enough. So, do you have a strategy, or is it on your map, or you just develop and then see what happens?
So a couple points. While everyone and their brother seems to be talking about deep learning, privately, as you talk to the various folks, you'll realize that there really aren't a lot of people investing in that. So unfortunately, just let's focus on the Silicon Valley ecosystem for the moment. There's market dynamics there that are driving that perception. I can't remember which startup this was, but I had a conversation with one where the CEO was like, oh yeah, we're doing deep learning, but we don't really need to do it. But the message was basically that's a backup, right? Because when you've got Google, Facebook, Twitter buying anything that moves that says it's deep learning, right? And doing acqui-hires or acquisitions to get that talent, get that expertise in the door, and literally like they're canvassing people from all over the world. Yeah, it's not a bad backup plan to say you're doing deep learning, and to actually maybe build up some expertise, like if your mainline business doesn't actually succeed. And for most people, that's exactly what happens. And yeah, I think the reality is that in many cases, unless you, for some strange reason, like absolutely convince yourself you need to go down that road right away, like using shallow models, you you'll be just fine, right? And if you just need an 80% solution to get the job done, and oh, by the way, you're iterating, you're still trying to figure out like what problem you actually need to solve that, you know, that will actually lead you to a product that has some market viability. Like, why would you waste all the time? You need to do that. So it just doesn't make a lot of sense. I mean, it's the big boys that can make that investment, the good boys that fix books. Even Twitter, right? I mean, they bought an amazing optimization company, and we're all still scratching our heads like, what are we do with that? It's not what they make.
Yes, my experience is that you need to have like a big enough data set, because otherwise,
Oh, that's true. That's right.
deep
Yeah,
learning is
got it.
just like, building too sophisticated models, and it's overfitting on data, and
That's
like,
right.
you end up with worse results than doing SVM or something else.
Yeah, exactly, and I think that's, if you look at where the advances are happening, with the application of deep learning, it's in text and basically computer vision models, right? Where, yeah, if you're mining at web scale, sure, I can learn like 500, different object classes and train over a gazillion images. That's a nice luxury to have, but most of us don't have that.
I have another question. So you're a startup in stealth mode, so you still have to release your product, right? But you're using machine learning, you're building models. How do you deal with the cold start issue? Where do you get data?
Well, so for the problems that we're working on, which are really kind of fall in the realm of enforcement legislation, and given the application domain that we're working in, the marketing domain, for the algorithms that will go to market in our very first product, we can basically simulate data. We can generate synthetic data and exercise the system quite well. For kind of more advanced things that we have in mind down the road, you can still do some things synthetically. You're not going to obviously get all of the fidelity that you get from live data. But I'll tell you just, the way I work whenever I'm doing that kind of algorithm development, it's, there are times when you're going to work on the real data and you're going to go learn some painful lessons there, and then sometimes like as you're doing that, you're going to get stuck and you're going to be like, wow, I'm seeing behavior here that I do not understand. And then, or at least my design pattern or my kind of mode of operation is then I will, if I fundamentally don't understand the behavior of the algorithm, I will generate toy problems where because I synthetically generated the data, I engineered exactly and had precise control over various conditions. Then I can revert to that to recover things about the algorithm that I maybe didn't understand, remove the mystery, and then go back. And so there's this kind of alternation, at least the way I work. And it's a real art. I've led teams in the past where I had some world-class guys on my team, and they would get stuck. And like when we started kind of veering into the unknown and no one had published on stuff we were figuring out, they would kind of come to me and be like, well, yeah, we don't know what to do, And then my contribution, even though I wasn't supposed to be down in the weeds, is I'd come in and be like, okay, let's craft it this way. Let's simplify it. Solve a simpler problem that we can actually visualize the results and so forth. And just kind of walk through that experience. And it's really interesting to see that just, another contrast between like software engineers that I work with in the past and that kind of work, it can be extremely emotionally draining. Because like one of my past software engineers who was also, he's a gifted machine learning engineer, I would say. He told me, he said, when I'm just writing code, like I can crank out 500 lines of code in a day and like I felt like I did something. Versus like when I'm banging my head against some algorithm and 12 hours goes by and like I'm basically where I was at the start of the day. especially when that goes on for days. Or in my case, I had one problem we were working on. And again, it was just me working on it, which is even more painful. Where weeks went by where I was like, I'm not sure what's going on here. And then finally lightning struck and I was like, oh, I think I know what's going on. And then I found a reference in the literature, literally one sentence where somebody said, oh yeah, this controls that. I'm like, yeah, no shit. Like, boy, did I have to go through a lot of pain to really understand that problem. But boy, do I understand it.
I think it's another good point though from a productization and product building perspective. When you're building machine learning based products, you have to have this kind of backup strategy so that you have some sort of sanity check. You can move fast, you can be agile, and keep up with the pace of the engineering stuff. So it's the ability for these guys to collaborate at the same kind of pace and cadence and kind of match one another, not just in vocabulary, but also in working style.
Yeah. And I'm learning lessons working with these guys. I mean, that's tough, right? You know, things that keep me up at night is when I'm, you know, trying to communicate to the rest of the team what I'm struggling with and what is my level of certainty about when I think I might be able to solve the problem. But in any one of those estimates, I always have to tell them, like, there could be a black swan event out there, like when I run right into a brick wall, and I'm like, wow, yeah, there's something weird going on here. And then I'm like, I'm in the dark room, and I don't know where I'm like, hey guys, I'm gonna go try to figure out where the door is. I'm not sure how long this is gonna take. And then we have conversations about how to hedge that risk. But that's challenging.
Okay, is there any other question for the speaker? Or for the guest? Okay, then let's thank the speaker.